Okay, so the next question is why do model overfit? Why do models overfit and how do we prevent it? Oh, so yeah, okay. Okay, let's start. So the question is why do model overfits and how do we prevent the overfit? So let's talk about why overfitting happens when when a model learns training data to specifically while including noise, outliers, and accidental patterns instead of learning true general patterns. So why overfitting happen? Because uh, overfitting model memorizes the noise because our model has too much freedom. Has too much freedom and less constraint. So basically, our model is too complex, too much freedom, but less constraint. Okay, so let's talk about how do we recognize whether it is overfitting or not. So in simple term, we can recognize checking our monitoring uh, by the training performance and validation or test error. So if our training error is very less and validation error is very high, so it is the gap. So it may be overfitting. So in order to check or confirm, so we just add regularization. If after regularization our training our validation error is reduces, it means our regularization can reduce the overfitting. So it is overfitting. Okay, and so let's talk about what is the causes. What is the why overfitting occurs? So what is the causes of the overfitting? So I think 6 to 8 causes. I think 6 causes, the most important causes of the overfitting. The first one is uh, complexity of the model. The first one is complexity of the model. If our model is too complex related to our data or our training data, for example, our training data is very small and we built a very complex model. So it is chances that our model memorizes all the data set and it becomes overfitting. Yes, for example, like uh, yeah, 100. For example, I have built a model with 100 depth decision tree, and the data set is 500 samples. So there is chances of overfitting. And the second one is our data set. Our data set is too small data set. And also the quality of data is not up to the standard. So if our data set is small, so it is possible that our model memorizes all the noises, and also so this is also one important cause. And so for example, fraud detection, we have used only 200 models, only 200 samples for the fraud detection. So it is basically our model memorizes the whole data set. And third one is like our data set has many irrelevant features or leaky features. So our model has many irrelevant features like for example, in our data set we have IDs column, ID features. So an ID is very large number. So maybe it's possible that our model learned that this is the important features, but it was irrelevant features. So so this is also one of the cause of overfitting. And and the fourth one is lack of regularization. So actually, in order to prevent overfitting, we add regularization before training. So regularization is very important, but if we don't have regularization, so it is chances that our model may overfit. So yeah, because regularization is nothing but it is constraint. It is the constraint. So basically, it reduces the model complexity. Okay, so and and the and the fifth one is uh, fifth one is like training our model for too long. So this happen in mostly in deep learning. For example, we are training our neural network for too long, so our training error become very less, but our validation error is high. So yeah, it may causes the overfitting, because it it learned too much. And the last one, I think uh, sixth one is data leakage. So data leakage is nothing but like during training information is available, but during validation or testing or inference time, information is not available. It is happen like, for example, in claimed uh, insurance claimed that is a feature available during training, but during testing it is not available. So it is data leakage. This cause overfitting. Okay, so and these are all the causes of the overfitting. Let's talk about how do we prevent the overfitting. What is the solution of overfitting? Okay, so let's talk about one by one. And the first one is like increase the data set. First one is increase the data set and quality of the data set. Increase the data set and quality, also the quality of data increased. So if we increase the quantity of data, increase the training samples, increase the training sample, reduce the duplicate samples, and also reduce the uh, wrong labels. So our model performance will increase, and overfitting, the chances of overfitting will reduce. This is the first one. And the second one is regularization. Regularization is very important. So this is one of the most common way to handle overfitting. So regularization is basically add the penalty to the loss function. And how does it work? So basically it adds penalty to the loss function, and it basically reduces the complexity of the model by just giving applying the penalty to the large weight parameters. So how does it work? So there are actually let's talk about a number of types of regularization. There are actually three types of there are actually two most common regularization techniques. The first one is L1 lasso, and yes, L1 regularization, and the second one is L2 regularization. The first one is so like the formula is loss is equal to MSC, mean squared error. This is for regression, and mean squared error plus, and the penalty which is added by the regularization, lambda into summation of mod of wi. It adds the penalty in terms of absolute value. And we know that mod w becomes 0 at 0. So it is at corner, it becomes 0. So it works like so basically L1 regularization makes some features irrelevant by adding its weight is 0. It weights 0. So it is L1 regularization act as a feature selection. So it basically makes some weights to 0. Okay, and let's talk about the second type of regularization, L2, which is by default we use ridge regularization or L2 regularization. It adds penalty to the is in squared form, quadratic form. So like loss is equal to MSC plus lambda into summation wi square. So yeah, so it actually it never makes any weight to 0 or any features become irrelevant. It basically shrinks the weightage of most of the most of the features. So yeah, so if our features weight is very large, so it reduces its weightage. And yeah, so these are, yes. So this was the second. And let's talk about the third one is also very important, cross validation. So actually, so if, for example, if we have very less amount of data set and we don't have option to increase the data set, so what we do is just use k-fold cross validation. So in k-fold cross validation is basically divided the whole data set into k splits, and we perform training k times, and at each time we just train on k minus 1 splits of data, and the and the and the one split is used for the validation, and it applies k times. So every time it gives the error, and we just perform, at last we just apply the averaging. So it generalizes very well, and basically it, so in cross validation we basically are trained on each and every data set, and also perform testing on each and every data. So yeah, cross validation. And the the fourth one is early stopping. So early stopping method is basically used in deep learning. So whenever we have so for example, uh, when our training error is less, and but validation error stop uh, stop reducing the stop stop increasing the performance, stop reducing the error, so we just stop the stop the training. So it is also very good. And the last one is a simpler model. So in our, so for example, if we have very less amount of data and we don't need very complex models, we just simplify the model complexity. We just use simpler model. For example, instead of using 100 node depth decision tree, use ensemble method. So yeah, and actually the order of solution is also very important. The first, I think, when overfitting occurs, so we just use first careful cross validation, and then we add regularization, then we check for the data set, and in that order. Thank you.